Your teacher today is Dr Bbosa Science. Today, 7th June 2019, we are going to consider colligative properties. When a non-volatile solute is dissolved in a solvent, the boiling point of the solution is higher than the boiling point of the solvent. The difference in the boiling points of the solution and the solvent, given by a symbol dt, is proportional to the mass of a solute and inversely proportional to the molecular mass mR of a solute dissolved in a specified mass of a solvent. The difference in the boiling points of the solution and the solvent, we have seen that the boiling point of the solution is higher than the boiling point of the solvent. So when you subtract the boiling point of the solvent from the boiling point of the solution, we get dt. So we are saying that dt is proportional to the mass of a solute and inversely proportional to the molecular mass of a solute dissolved in a specified mass of a solvent. In other words, dt is proportional to m over mr, and dt is equal to kb m over mr. Whenever you remove a proportionality sign, we put a proportionality constant kb. Kb is called boiling point elevation constant or boreoscopic constant. By definition, we are saying that when m is equal to mr, then kb is equal to dt. So you can define kb as elevation of boiling point of a given mass of a solvent by 1 mole of a solute. Usually, the mass of a solvent is 1000 grams or 1 kilogram. Application is of kb to determine the molecular masses of solutes. Then limitation. If we are to get accurate results for molecular masses, the solute must be non-volatile, the solution must be dilute, the solute should not react with the solvent, the solute should not associate or dissociate. Then the molecular mass of a solute should not be very big. Since the solution is of solutes with high molecular masses, give negligible boiling point elevation is. Experiment to determine boiling point elevation constant. The main challenges is superheating of a solution. Superheating of a solution is said to occur when the solution boils at a temperature higher than the normal boiling point. Then 2, insensitivity of thermometers. Usually a Bakerman thermometer is used because it is a bit accurate. It measures in the order of 0.1 degree Celsius. Method A is the Colligative method. The setup is given below. In this method, the bulb is heated by vapor and does not touch the liquid to minimize the error due to superheating. First, the boiling point of a given mass m1 gram of a solvent is determined. Then a given mass of a solute of molecular mass mR is introduced through a side arm, and the boiling point T of the solution is determined. Treatment of results, we have seen that mass of a solvent is M1, mass of a solute is M2. Then boiling point elevation dt is equal to boiling point of the solution minus the boiling point of the solvent. Molecular mass of a solute is Mr. Then the mass of a solute in 1,000 grams of a solvent will be equal to 1,000 times M2 over M1. Or M1 grams of a solvent contains M2 grams of a solute. Therefore, 1,000 grams of a solvent will contain 1,000 M2 over M1. Then Kb will be equal to boiling point elevation times the molecular mass of a solute times the mass of a solvent over 1,000 times the mass of a solute, where Kb is boiling point elevation constant. Method 2, Landberger method. The setup is as shown. 1. The solvent is boiled by the vapor and the boiling point T0 is determined. 2. Mass M2 grams of a solute of molecular mass Mr is introduced and the boiling point of the solution T is determined. The final volume V is determined. Mass of a solvent will be equal to Vd, where D is the density of the solvent. Mass of the solute is M2, we have already seen that one. Then the molecular mass of a solute is Mr. Then the T temperature change will be equal to T minus T0. We have seen that the boiling point of the solution is higher than the boiling point of the solvent. Then mass of solute in 1,000 grams of solvent, we say that Vd grams of solvent contain M2 grams of solute. Therefore, 1,000 grams of solvent contain 1,000 M2 over Vd. It implies that T minus T0 degrees Celsius is caused by 1,000 M2 over Vd, and Kb, which is the Bbosa constant, which is Kb, which is the boiling point constant, is caused by Mr. Therefore, Kb will be equal to this times this over this will be equal to T minus T minus T0 times Mr over 1,000 M2 over Vd, which is equal to T minus T0 times Mr times Vd over 1,000 M2. This will be degrees C per mole per kilogram. Kilogram is 1,000 grams.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Example 1, the boiling point of ethanol is 78 degrees Celsius. Calculate the boiling point of a solution containing 2.7 grams of ethanamide in 75 grams of ethanol. The boiling point elevation constant for 1000 grams of ethanol is 1.15. First we get the formula mass of ethanamide. Formula mass of CH3CONH2 will be equal to 12 plus 3 for hydrogen plus 12 plus 16 plus 14 plus 2, and this is equal to 59 grams. Then we get the mass in 1000. Mass of ethanamide in 1000 grams of ethanol. Mass of ethanamide in 1000 grams of ethanol. We have seen that 75 grams of ethanol contain 2.7 grams of ethanamide. We have seen that 75 grams of ethanol we have seen that 75 grams of ethanol contain 2.7 grams of ethanamide. Therefore, 1000 grams of ethanol contain 2.7 times 1000 over 75, which is equal to 36 grams. But 1 mole of a solute causes the boiling elevation of boiling point constant, but 59 grams of ethanamide cause an elevation of 1.15 degrees Celsius. 1 mole of a solute in 1000 grams of a solvent will cause an elevation of Kb, or boiling point constant. In this case, it is 1.15. Therefore, 36 grams of ethanamide will cause 1.15 times 36 over 59, which is equal to 0.7 degrees Celsius. But the boiling point of the solution is higher than the boiling point of the solvent by the T. Therefore, boiling point of solution will be equal to 78 plus 0.7, which is equal to 78.7 degrees Celsius. A solution that contains 5.5 grams of A in 125 grams of water boils at 100.139 degrees Celsius. Calculate the molecular mass of A. the boiling point elevation constant K for water is 0.52 degrees Celsius. First we get dt is equal to 100.139 minus 100 degrees. We know that water boils at 100 degrees, so this is equal to 0.139. Then mass of a solute in 1,000 grams of water. Then we are told that 125 grams of water contains 5.5 grams of A. Therefore, 1,000 grams of water contains 1,000 times 5.5 over 125. Water is the solvent, which is equal to 44. Now we want to get the molecular mass of A. We know that if the molecular mass of A is mR, causes an elevation of 0.52 degrees Celsius. One mole of a substance will cause an elevation which is equal to Kb, or which is equal to K. But we are given that 44 grams of A cause an elevation of 0.139 degrees Celsius. It implies that molecular mass of A will be equal to this times this over this is equal to 0.52 times 44 over 0.139, and this is equal to 164 grams. Therefore, molecular mass of A is equal to 164 grams.
Mutima gwange agira nze n'essomero lyange agira nze n'emikwano gyange lino ggwanga lyange ono zabu waffe olw'ebirungi byeleeta waliyo ebinyuma laba ebiwalanfa emisono buli kimu kibeereyo tuwagire timu yaffe tugweyo tuwagire eggwanga lyaffe asobola azanya anyumisa muzeeyi ateeba agwira 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 Dr Bbosa agwira muzeeyi ateeba